This video is going to cover the topic of calculating probabilities with unequal outcomes. Be sure the date and topic are at the top of your page. The essential question for this video asks, how do we calculate the probabilities of multiple events happening, especially if they have unequal likelihoods? We're going to start with a table about Miss Melissa and the likelihood of her buying apples when she goes to the orchard. I'm going to ask you guys to make a copy of this table in your spiral. And I want to point out that I'm going to be using decimals to show the likelihood instead of fractions or percentages, but it all means the same thing. I'm just using decimal form. And I want to point out that when Melissa gets to the orchard, it's not equally likely that she'll buy any number of apples, right? You can see here that she's more likely to get 5 apples by the time she gets all the way out there than she is to just get 1 or 2, right? So it's not all equal. And I want to point out one more thing, and that is that our probability should always add up to 1 or 100% depending on how you're doing it, right? Remember that 1 represents certain. So if I add these up just as a quick check, if I was adding these, I would see that indeed this does equal 1. So I know that that's a nice complete list, right? That is all of my values. It adds up to 1. So one of those things is going to occur. Now that we've checked that, let's look at the topic of this video, which was how to calculate the probabilities of multiple events happening, especially if they have unequal likelihoods. So I'm going to pose a question. And that question is, what is the likelihood that Melissa buys either 2 or 3 apples? So we know, let me just use a color here, we know that she has 1/10 probability of buying 2 apples, and she has 2/10 probability of buying 3 apples, right? So if we want to know the total chance of her getting either 2 or 3, we simply need to add those together and say, oh, she has a 3/10 chance that she'll buy either 2 or 3 apples, a 30% chance, right? We can also say that as 30%, a 30% chance that she'll walk away with either 2 or 3 apples. I can ask the same thing, this time asking the likelihood that Melissa will buy either 1 or 2 apples. So 1 apple had a 1/10 probability, and 2 apples also had a 1/10 probability. So together that makes up a 2/10 chance or 20% chance that she'll walk away with either 1 or 2 apples. Notice that when we want to find the combined likelihood, we add the probabilities together. And notice also that there was a subtle word that I used that helped me to realize what I was trying to do here, and that was the word or, right? That's when I'm trying to have 2 independent things. I don't care which of the 2 happens, but one of them needs to happen for my success or to satisfy my question. So that's true also if I ask this one. What is the likelihood that Melissa will buy at least 3 apples? Now this time it doesn't say the word or, but what I'm really looking for is how to satisfy this question, which is that she could buy 3 or 4 or 5 apples. And since it's 3 or 4 or 5, right, I would have to add up all of those likelihoods to find the sum of all 3 possibilities. And of course that would mean that there's a 70% chance, it's pretty likely, that Melissa will buy at least 3, the 3 or 4 or 5 apples, 70% chance total. When probabilities are listed in decimal or percent form, this process can be pretty quick, right? But sometimes, as we know, they're listed in a ratio form that looks like a fraction. If we look at this spinner, right, hopefully it makes sense to you, this is a bit of an approximation, that we have here a 1/2 chance of landing in the blue section, right, because blue takes up half of the space. However, this green section, right, this is half of the half, so the green is actually only 1/4 of the space, and the red also takes up 1/4 of the space, right? So now we have these in fraction form, and I'm going to use really friendly fractions to show this, but we might want to know the probability of getting one of 2 colors. So let's say we spin a spinner, and we'd be happy if we get either blue or, there's that word again, blue or green, right? Either one of those would be great. So I want to combine those options. Well, blue is 1/2, and green is 1/4, right? And we should remember, back to adding fractions, that this does not equal 2/6, right? No way, no how. That does not equal 2/6. To do this, of course, you would need to find a common multiple to use as a common denominator. And in this case, the nice friendly common denominator they both have is 4, right? Multiples of 4 work for both of these. 1/2 would become 2/4. 1/4 would get to stay the same. And then, of course, we can add that up and we get 3/4. So the chance that a spinner would land in either blue or green is a probability of 3 out of 4, right? Or 75% chance. Right? Of course, this was a simple example. Many times fractions require much more work. But the essential question of this video was, how do we calculate the probability of multiple events happening, especially when they have unequal likelihoods? And now we know that if different results, different outcomes could satisfy what I'm looking for, then I would need to add the probabilities together. Be sure to have your notes ready when we get to class.